Hello, and let's look at a class Q built out of an array. There in the red box, you'll see the code for the class Q implemented with an array. As always, an array comes with the problem, what size should the array be? We're going to eliminate that problem a little bit by letting the user or the creator of the Q set the size of the array this time. An additional problem we have with a Q is a shift. Do we have to move items when we insert or move? To avoid the shift, this code is going to use a technique called wraparound, where we reach the end of the array, we wrap data back around to the beginning. We'll trace this code when we build a queue. Breaking down this code a little bit, we have variables at the top. That's where I'd like you to declare your variables. Also notice that all the variables are declared private. We don't want anyone outside the queue accessing these variables directly. This is the data portion of the queue object. Max is the size of the queue array. How big are we going to make this queue? For space reasons, we're going to use a small max here, but we'll allow it to be set to anything we want. Do we want to store 5 items in the queue, or 50 items in the queue, or 500 items in the queue? Max is going to determine how big the array is and how many items we can store in the queue. Front is the index or subscript in the array of the first in item placed in the queue. So it will be the first out item. Remember, queues implement FIFO, our first in, first out. The front of the queue is like the front of the line. Back is the index or subscript of the end of the queue, or the back of the line. That's why I like using these variable names front and back. A queue is a line. You wait in line to buy books for college. Num is the number of items in the queue. Are there currently 0 items in the queue, or 1 items in the queue, or how many items are in the queue? Finally, QArray will hold the values stored in the queue. Obviously, QArray is the array where we're going to store values. That's the data portion of the object. Now look at the methods. The methods are the actions a queue object will perform. We have a queue constructor to initialize the variables. Note the parameter for max. The user sets the size of the queue. When they're building or constructing their queue object, they determined how many slots we're going to allocate in the array. This is a much better technique for allocating an array. It lets the user decide what the proper size is. Next, we have an insert method, which will place a new item at the back of the queue, or the back of the line. Remember, a queue implements a line. The first person in the line should be the first one to get to the counter. The last person, or the new person that shows up, should go at the end of the line. So insert places a new item at the back of the queue. The remove method will remove and return an item from the front of the queue. If you are at the front of the line, you expect to be the person that goes next. The remove method takes an item off the front of the queue, or the front of the line. So let's look at some code that builds and uses a queue object. This first line of code declares the reference variable the queue and calls the constructor method to initialize the object. Notice the parameter of 5. Also look at where we built the queue object. We have a lot of variables in this: max, front, back, num, QArray. That's the variable portion of the object. And of course the methods are the constructor, insert, and remove. So let's execute the constructor. The value 5 is the maximum size of the array the queue is built from. Let's let the user or the creator of the queue object set this value. So if they think they need a small number, they can pass a small number. If they think they need a larger queue, they can pass a larger queue. So we're going to set m, which is this 5 passed to the parameter there, to the max variable, and we'll hold 5 in the max variable. This is going to be the size of our array. Building our array now, QArray equals new int max. We'll allocate the array object with 5 slots because that's what the user requested, and we will assign a reference to that object to the QArray variable. Let's initialize the other variables. Front equals 0. The front, or the start of line, will be position 0 of the array. Note the first item inserted in the queue will go into slot 0 of the array. Back equals -1. Let's set the back global variable here. You can see these values as I'm setting them get inserted into my object. Note prefix notation. There's a ++ back that will execute before the array assignment is done. That's why back can start at -1 and still insert the first item at 0. Our intention is for the first item to go into position 0 of the array. So with some prefix notation, we have to start back at -1. Num equals 0. This is pretty easy. The current number of items in the queue, which is 0, because it's a brand new queue. We haven't inserted anything into this queue. We have 0 items in the queue. So this is the initial values for our global variables. Let's execute the code and see how they change. Let's call the insert method and pass 11 as a parameter to it. Remember, 11 hard-coded is not a great idea, but I want you to see the items going into the queue, so it's just easier to use a hard-coded in this example. Obviously, in the real world, you'd probably be passing it a variable and saying insert the contents of this variable into the queue. So 11 will be assigned to the parameter it, and we'll execute the method. This first if statement is completely false. Back of -1 greater than or equal to 4 is absolutely a false statement, so all we're going to do is skip this entire if statement. Note, this is for the wraparound that we were talking about earlier. We will not be executing this until we reach the end of the array. Here's the guts of the insert routine. QArray of ++ back equals it. The value of the parameter it is assigned to the array at index 0, or the variable back. Note the prefix notation. +1 is done before the array assignment, so back changes to 0 before we do the assignment. At this point, front and back are both 0, since there's only one item in the front, and back are the same. Now at position 0, there is our 11 that showed up. We added 1 to back, made it 0, and then we assign the 11 into the array. With one item in the array, you would expect the front and back to be the same. If you were the only person standing in a line, you would be both the front of the line and the back of the line. Num++. First thing I want to point out on this line of code is prefix, postfix have nothing to do with it. This is a single line of code. Notice that semicolon there. Just add 1 to num and store the result in num. Since we have one item in the queue, add 1 to the variable num, which is the number of items. And you can see we now have one item in the queue. And you can visually see it. We have one item in the queue and num contains a 1. And again, this is very different situation here. See that ++ back? That is part of a bigger command. Do this first. This is a command all by itself. Just do this. So there we have it. We've inserted an item in the queue. Let's go back to the original calling code and execute the line of code after the call to insert. Here's another call to the insert method. This time we'll pass 22 to the variable it. Again, hard-coded 22s are not a great idea. Hopefully you'll be passing variables when you write real code. 0 greater than or equal to false. This will go to the next line of code. We are going to skip this if statement until we hit the end of the array. It's only for the wraparound. Until we reach the wraparound, this code will not execute. Let's assign QArray ++ back equal to it. There's the 22 going into the array. Remember the prefix notation. We do the +1 before, so back goes to 1, and then we insert the 22. At this point, front is 0, so the front of the queue is 11. Back is 1, so the last item into the queue is a 22. Only complicated part about this is understanding the prefix notation. ++ back happens before the array assignment. Num++ is all on its own, so we'll just add 1 to num. You can clearly see there are 2 items into the queue, so we've changed the variable num to 2. Add 1 to num and store the result back into the variable num. Returning to the calling code in the line after the second call to insert, and there's a third call to insert, and this time we'll pass 44 to the parameter it. So this 44 gets assigned to that variable it. We'll do an insert again. 1 greater than 4 is a false statement. You can see we're nowhere near the end of the queue, so this does not take effect. This is for the wraparound at the end of the array. So we'll drop down to the next line of code. ++ back will occur first, so back will go to 2 first. After back goes to 2, we'll assign 44 into slot 2 of the array, and there goes 44. Note the prefix notation. Add 1 to back and then do the array assignment. Front now contains a 0, so 11 is the first item in the queue. Back now contains a 2, so 44 is the last item in the queue, or is at the back of the queue. Num++ bumps to 3 because there are 3 total items in the queue. Back to the calling code. Time to execute a remove method. Call the remove to return the first item in the queue. That's what a queue is. It's a line. So the first item in the line needs to come out of the queue. We'll assign it to the variable frnt, which is short for front. As the name implies, item will no longer be in the queue. We expect to take an item out of the queue and assign it to the variable front. So let's follow this line and execute the code of remove. We'll say int temp equals queue array of front plus plus. The 11 at the front, or index 0, there it is. There's the front of the queue. There's 11 at the front of the queue. We'll assign that to the temp variable. Notice the postfix notation. Look where the red line ended. I'm not going to do the plus plus yet. The postfix notation says the +1 will occur after the assignment. So after the 11 is transferred, then we'll add 1 to front. Front just moved to position 1. When front moves position 1, that essentially removes the 11. 11 is no longer the front of the queue, 22 is. However, 11 is still in the temporary variable. We saved it there for safekeeping. So now that front has moved past 11 and 11 is out of the queue, it's still in our temporary variable. If front equals max, 1 equal to 5, front contains a 1, max contains a 5. Again, this is the wraparound. This will occur at the end of the array if we reach the end of the array. We are nowhere near the end of the array, so this code just skips past the if to the next line of code. However, we are removing an item from the queue, so it's time to subtract from num. Num minus minus. Note that the postfix notation has nothing to do when the -1 occurs. See that semicolon at the end of the minus minus? Just subtract 1 from num, make it 2, because there are now only 2 items in the queue. If there are 2 items in the queue, we expect num to be a 2. Up here, as part of a larger command, the postfix prefix makes a difference. But on a command by itself, it really doesn't matter. We could have done minus minus num here, or num minus minus, and it would have done the same thing because of that semicolon right there. Execute this entire command in its entirety before you move on to the next line. And here's the next time. We want to return temp. We want to send temp back and assign it to the variable front. The 11 is returned from remove and is headed for the front variable. We're back to the calling code, and we'll take that 11 from the temp variable and assign it to the frnt variable, and you can see 11 showed up in frnt. Frnt is just short for front. I didn't want to use the same variable name as my global variable front, so I just shortened the name a little bit. But it's still understandable that this is the front of the queue. This is the item 11 that was at the front of the queue. Notice also after that happened that temp was deleted. Temp is a local variable declared in remove. So when it disappears when remove is done. That's what happens to all local variables. When the method that declared the local variable is done, that disappears. After the 11 was safely transferred to the front variable, temp disappeared. So let's call the insert method again. Let's pass 33 and assign the 33 here to the variable or parameter it. Hard-coded 33s aren't great, but it's better for showing you an example. You can see the 33 show up in the queue. Back greater than or equal to max minus 1. That's a 2 greater than or equal to 4. That is a false statement. As a false statement, it will skip to the next line of code. Again, that's just for the wraparound. The real code here, queue array of plus plus back equals it. That 33 that was passed in has got to go into the array. Back increments to 3, and then we slide the 33 in there. Front currently is 1, so 22 is at the front of the queue. Back is currently at 3, so 33 is the last item or at the back of the queue. We've added a new item to the queue, so we'll bump num plus plus, and num will go to 3. You can see 3 items in the queue here. You could see num contains a 3. Num should always match the number of items in the queue. Turning to the code that called insert, and the next line is a call to remove. Remove the first item from the queue and assign it to the variable frnt. As the name implies, the item coming from the queue will no longer be in the queue. We are removing an item from the queue. So we'll be taking the front of the queue and sending it back to the user and deleting this off the queue. Create our temp variable. This is a local variable, so it gets created on demand. We'll take the value that's in front right now. Front contains a 1. We'll take that 22 and assign it to the temp variable. Note the postfix notation. We will not add 1 to front until after this assignment is completed. So front just moved up to 2. When front moved to 2, essentially the 22 was removed from the queue. Since front is no longer pointing to 22, it's pointing to 44. 22 is out. However, we have saved 22 in the temp variable. That's why we created temp in the first place, to save the item we were removing from the queue so we could later return it. Next, we'll check for the wraparound. 2 = 5 is a false statement, so we will skip this if portion completely and just drop down to the next line of code. Again, that's for wraparound at the end of the array. Num minus minus will subtract 1 from the num variable. You can see clearly there are 2 items in the queue, so num should reflect that 2 items. And we'll return temp. The 22 that's stored in the temp variable will be returned from remove and is headed for the front variable. The 22 from temp was assigned to frnt, and you can see we now have a 22 in frnt. After that, the temp variable was deleted. It was a local variable and disappears when remove is done. That is the definition of a local variable like temp. It gets created when remove runs, and it gets deleted when remove completes. Unlike global variables like max, front, back, they stick around. Global variables stick around. Local variables get created and deleted on demand. So we've now removed 22 from the queue and have it in a variable frnt, and we can do with it what we want at that point. Next up, let's call insert method once again. We'll pass a 51 this time to the insert method. So 51 will be assigned to the parameter IT. Hard-coded values aren't great. In your code, I would expect that to be a variable, not a hard-coded value like 51. 3 greater than or equal to 4 is still a false statement, so it will just skip past this line of code and go on to the next line of code. This is for the wraparound, and we're going to be seeing it very soon, I have a feeling. QArray ++ back equals IT. Add 1 to back first, bump back to 4, and after you do that, slide the value 51 into array slot 4. Note the prefix notation. We will add 1 to back before we do the array assignment, and that's how 51 ended up in slot 4. So the front of queue is now 2, so 44 is at the front of the line, or it's the first item in the queue. And back is 4, so 51 is at the last item in the queue, or at the back of the line. Num ++, we're back up to 3 items in the queue, so the variable num has changed to 3. And this postfix notation has nothing to do with the command. If postfix occurs on a line by itself, it doesn't matter. It's just going to add 1 to num, and we see num went to 3. Back to the calling code and another call to the insert method. This time let's pass a 23 to the parameter IT. Now we can see some wraparound. If back is greater than or equal to max minus 1. Well, back is now 4. So now we're looking at 4 greater than or equal to 4. We are at the end of the queue. We are at the end of the array. This is the wraparound. We are going to execute the code back equals -1. So at the end of the array, we'll wrap around back to the start of the array and put the new item at the beginning of the array. Back goes to -1. And it's counting on the prefix notation. Remember how we started at -1? So this prefix notation would put the first item at 0. Well, when we wrap around, we want to go to -1. So the prefix notation will make sure the next item goes in slot 0. This is the wraparound, and this is very important to implement a queue with an array using a wraparound technique. Let's see it in action. Queue array plus plus back equals IT. Back was not -1 long. The plus plus back changed it to 0. So then we slide the 23 in position 0. Prefix notation says we add 1 to back first. That's why the -1 went to 0 and the 23 slid into slot 0. Now look at the situation we're in. Front is equal to 2. So 44 is the first item, or is at the front of the line. Back is now equal to 0. So 23 is the last item in the array, or is at the back of the line. That's the wraparound technique. Do you see it? Also, now there are 4 items in the queue. So we plus plus num and we add 1 to num, and that 4 reflects the 4 items in the queue. Whew! That was a slide, wasn't it? As long as there are no more than 5 items at one time, the wraparound will continue. Note, there should have been better error checking in this code. I always feel guilty. We really should have some error checking in there. The insert method should check to see if num is 5 and not insert if num equals 5. The remove method should check to see if num is 0 and not remove if num is equal to 0. We need a couple of if statements over here to prevent over inserting an array. We need an if statement here to make sure that we don't try to remove an item that doesn't exist. But other than adding a little error checking and not using hard-coded values over here, this code fairly represents a queue implemented with an array using the wraparound technique. When we run out of room at the end of the array, we wrap around back to the beginning. Front would do the same thing. If we start taking items off of front, front would wrap around to the beginning too.